Hi, welcome to the video on how to write the equation of a line from an application problem. Now here we have a woodshop purchases a dust collection system for $18,700 and it will be depreciated over a 5-year period when its salvage value will be $2,700. So if Y is the value of the dust collection system after X years of use, we want to write the equation of the line of depreciation. And a lot of times straight line depreciation is what's used for tax purposes. So whenever we want to write the equation of a line in any situation, we need to find the slope, we need to find a point, and then we run that information through y minus y sub 1 equals m times x minus x sub 1, the point slope form. And remember, just for notation wise, the slope is often designated m. Our point we can designate as our x sub 1, y sub 1. And that can be any point on the line. So now what we do is we look at the information that we have whenever we want to write the equation of the line and see if they just hand us this information or if we have to work for it. So when we come back up here to see what we have, we've got the X is the years of use and Y is the value of the dust collecting system. So when we look for the different things that talk about the years of use, it purchases the dust collection system for $18,700. So we're talking about that being our 0 years of use. And then it will be depreciated over a 5-year period. So our 5-year is a value for years of use and 0 is a value for years of use. And then for the value of this dust collecting system, when we first get it, the value is $18,700, and after the 5-year period, the value is $2,700. So it's important to be able to designate and sort out what your X is and then what your Y is. So from this information, we do have 2 ordered pairs. We have the ordered pair when we have 0 years of use. It's $18,700 for its value. And we also have the ordered pair after 5 years of use. It's $2,700. And so that gives me my x sub 1, y sub 1 for my first point, and x sub 2, y sub 2 for my second point. So now slope. They did not hand me the slope. So I need to look at the information that I have and try to extract where I can find the slope. Well, we know from previous work that we find the slope when we're given 2 points from the formula. And we'll just do our slope work over here. That our slope, if we have 2 points, is the difference in the y coordinates, so y sub 2 minus y sub 1, over the difference in the x coordinates, x sub 2 minus x sub 1. And then here we are going to just go to where we've marked our coordinates and plug them in. So y sub 2 is our $2,700. So that's 2,700, and then minus from the slope formula, and then y sub 1 is our 18,700, and then in the denominator, our x sub 2 is 5 minus our x sub 1 is 0. So working this out, I have m is equal to, well, 2,700 minus 18,700 is a negative 16,000. divided by 5 minus 0 is 5. So that gives me m is equal to negative 3,200. So that's our slope. And now our point, we could really use either point, but we'll just go ahead with the one that we already called x sub 1, y sub 1. So our point is the 0, 18,700. Now we are going to go ahead and run this through the point slope form, and then we'll talk about like what situations you might be able to get to the final simplified equation quicker. So here we have y minus y sub 1, y sub 1 is 18,700, minus the slope, or sorry, equals, and then the slope is negative 3,200 times x minus x sub 1, and x sub 1 is 0. So this gives me y minus 18,700 is equal to, well, in this special case, x minus 0 is just x. So I just get negative 3,200 times x, so negative 3,200x. Normally, when my x sub 1 is not 0, I would distribute that negative 3,200. And then add the 18,700 to both sides. We get y is equal to negative 3,200x plus 18,700. And that is our equation of the line of depreciation. Now, just as a side note, just because this point is the y-intercept, the x-coordinate is 0. So when the x-coordinate is 0, I know that's the point that's the y-intercept. Specifically and only when you have the point that's the y-intercept, we could have written this equation quicker by the slope-intercept form. And we would have written y equals, our slope is negative 3,200x plus 18,700. And we would have gotten that equation right away. But that only works when you have the point that is the y-intercept to get it that quickly. Otherwise, there's other solving that you have to do. Had we used the 0.5 comma 2,700, we would have put the 2,700 in for the y1, the 5 in for the x1 in the point slope form, distributed, added the 2,700 over, and we would have gotten the exact same equation. But when you have a general point in the plane that's not the y-intercept, then you can't just jump to the slope-intercept form. You have to go through and do more simplifications to get your equation. Well, thank you for watching today.